Thank you for coming out. I know it's a weekday and we've all battled traffic through 237s and 101s, but then we made it here. So thank you, Aaron. Thank you for the sponsors and UX Southway for having me here. It's been a while since I spoke at a forum like this, and I'm excited to be here and looking forward to see how things go. So a little bit about me. I'm Brighton. I work for Nutanix. You heard we are hiring as well. So I work as a staff user experience designer, kind of lead the efforts around visualizations and a multi-product portfolio. So that's what I am today, but my career, however, did not start there. I started as this full stack engineer coding those data algorithms and data processing engines. But somewhere along the way, though my left brain remained fairly analytical, my heart decided to go towards the creative space of presenting and consuming these data. And so here I am, 10 years into my professional career, still fighting this marriage, trying to solve this battle between my love for data and the user experience. And in this process, I enjoy sharing and unraveling the stories that these data hold. Before we get started into the presentation, just to get a sense of who is in the room today, would we have a show of hands of all the designers, please? All right. Engineers, full stack, software, okay. Maybe any design managers, product managers in the house? Oh, wow, you guys have made your distance from the rest of the crowd here. Data ninjas, the data analysts, the business analysts. All right. Am I forgetting any significant role here? Okay, visualization engineers and visualization designers. All right, I don't have none. I have none here, so there's no way to fact check me today. There's a wide gamut of people in the room, and though we might not be seeing eye to eye on a lot of things in our day-to-day work, there's one sentence that we kind of agree to on different levels of confidence in this one. It goes, data is the new, yes, oil. This quote is over a decade old. It was actually credited to a mathematician. I was surprised that this was said in 2006, but then it has recently picked up a little bit of traction in our industries. And one of the reasons is The Economist in 2017, around this issues around data privacy and all these social media coming up, actually for the first time claimed explicitly that data has actually turned to be more valuable than oil. And since then, it has become our go-to quote. It has become our buzzwords wherever we talk about optimizing our business decisions and using them to drive financial goals as well. In fact, in the last 2 decades, we've seen that this data has actually turned job titles. The data scientists, the data analysts, and the business analysts have actually grown in numbers specifically over the last 10 years. And this has had the attention of every function in the company, be it engineering, marketing, sales, design, or even the president of the country for this matter. So, but is this really the oil? Equating data to oil seems right at first glance. Like, given the financial-driven success of all these companies, the analogy, however, tends to break down when you start to dig a little deeper here. The thing with oil is once a company finds its ground, it has a straight linear process towards making value out of it. Simply as in like drill, excavate, refine, and sell. There's a structured process towards getting from once you've landed on the ground to making money out of it. But this is far from reality when you think about this when dealing, especially when you deal with data. It is unclear about how you actually transform this data into profits. You could think about having an infrastructure to collect the data, then understanding and making sense of the data, doing your analysis on top of it, doing your data cleanup and weeding out those outliers, and then deriving business insights out of it. Wait, I just said there was no similarities. But this is, though you stack up this way, the thing with data is, unless you know the business insights, you really don't know what you're looking for or where you want to find your data. It's more, it goes like you, from your business insights that you want, you try and reach out for the sources of the data, then collect those data, and then from your hypothesis, you build your validation by analyzing these data, removing those weeds out of it, and then turning them into oil, the business insight. What we talked in the last 15 seconds actually describes a user-centric design workflow. You start with the user goal of business insight. You do your research to collect the data. Then you explore options and design, and then finally build your product out of it. This makes design a critical player in a way, not just the data, in not just the way the data is consumed, but also in the way a data is excavated, presented, and a lot more around the life cycle of a data in a product. Let's change tracks a little bit here and kind of spin our little narrative now. When life gives you lemons, you make a lemonade. 2-on-2 here today. So how many of you have played the game called Lemonade Tycoon? All right. I see a few heads nodding here. So you can help me with the narrative on this one. For those who haven't played, it's just a simple game. It's a business strategy game that does over simulation. You put up your lemonade stalls, buy lemons, sell lemonades, make profits, grow your business, and goes on and on. Perhaps you probably saved a lot of life, not a lot of hearts in your childhood, not playing that one. But here's how it goes. You open a lemonade stall. You sell it at a price. Let's say you sell it at a 25. Let's say you buy lemons at a 10 cents, and go 1 lemon per lemonade and make a profit of 25 cents. Then your business grows. Now you say, okay, I'm going to invest my money buying more strawberries. Now, in addition to my regular lemonade, I sell strawberry lemonade, putting it at a 5-cent more price. Then you start to expand. You build more of these in your locality and your neighborhood. You expand, and then the next step is start to diversify. You realize that in certain localities, certain type of lemonade sells better. So you start to specialize these shops. Some of them may just sell the regular one. Some of them both the strawberry and this, and you get the game how it goes. Then you expand, and now, if the game was made now, you would actually be building. You will actually be selling lemonade at the stall and also to goes or even DoorDash it. But basically, you tend to grow your business on this game, and until the doomsday hits. Do you remember what's the typical doomsday in this Lemonade Tycoon? When does your profit sink? It's usually related to a rainy day. When the rain hits, nobody comes to your store, or when the temperature goes down, nobody wants your ice cold lemonade, and everybody's looking for a hot drink, and you don't have it, and you let your lemons rot. Your profit goes down. You close down stores. Now, at this point in the game is when we start to pay attention to the details. You start to look at things a little bit different here. You start to keep a close eye on the sale. You start to optimize your produce purchases, maybe reduce the number of lemons or strawberries that you're buying, and you start to offer discount. This is the first point in the game you actually understand the business value of data. You're using your data to drive your business decisions. Now that you've outsmarted it, things get back up again. And like all happy ending movies, the business is back, and you expand more. You start to see these patterns in data in the gameplay, and it comes to a point where you've actually outsmarted the game, and you see these patterns, and you exactly know how to outsmart the game, and thus the game ends for you being interesting. Let's flip this narrative a little bit here again. This time, let's think about it in a more Silicon Valley style. Your real-life organic vegan juice venture is now making millions of dollars. And what you do, you've hired a software team because you learned that your data is what is helping you make these decisions. So the software team works day and night, crunches those numbers, and as a first step, they help you structure the data. As a first step, they might provide you tables. So every time a shop comes up, they start to analyze the profit and expenses that's made on this one. So you start to slice and dice these data, get different points of view. And the next step, your engineer goes back and produces reports that contains visualizations like these ones that summarizes your sales, revenue, profit, your sources, comparing them with competitors and such. And these reports start to influence your business decisions. And going further, then you start to see and manage these things a little bit differently. You use visualizations to manage and optimize. Here's an example of something like a produce workflow from farms to your fruits and vegetables, going into the different shops, lemonade shops owned by different managers here. Now you realize that you've built a product that's powerful enough that might actually go beyond this use case of a lemonade store. You see what I'm doing here? You start to productize this. You want to sell this software to other markets. That's season 2 of Silicon Valley. Let's not go there. Let's roll it back. So what you saw here was your transition of your business from a single numeral on a chalkboard to a more complicated softwares where you are managing supply chains in real time. And your data experience, on the other hand, moved from simple presentation of informations on chalkboards to like structured tables that pivoted and gave you different views to actually a form now that promises to stand the test of scale and time in the form of visualizations. And you begin to embrace data visualization as a way forward and scale up. And all looks good so far, but not really. While you are focusing on the greener side of the grass, your processes and habits that develop kind of crept in some weeds into this one. You are scaling your product teams, but then you realized the process and the habit that got built into the scaling team wasn't really effective for you anymore. Let's say, Kate, your first UI engineer on the team, built a set of visualization for your stores application. And Mario simultaneously built a set of visualizations for your inventory applications. You realize that they were building these visualization systems and data experiences simultaneously, and the forms in which they have come out, though might be representative of a bar chart, but fundamentally, or not fundamentally, but starkly different in ways. Could be different in terms of visuals, interactions, or the way in which it was presented in the product. And when the team grew, Irene, Alex, and Joe came into the party. They copy-pasted the code made by Kate and Mario, and they added more visualizations and added more functionalities over them. Eventually, you had more visualizations in the product, but they were copy-pasted from different versions of the code by different developers, and you have no insights in or have a holistic view of the state of the data experiences in your product. A few months down the lane, let's say about a release that's looking into a month from now, your QA identifies a bug on one of Irene's charts. But by then, you've already replicated that issue into 8 other places. This is even before your first release. This is just the tip of the iceberg of the problem we are talking about. Let's assume that your business grows and you're being acquired, or even better, you are acquiring another company. Maybe there's something that's selling hot dogs. And if you get really lucky, you might get something like this, a uniform product that's actually standardized and that looks consistent. But what you actually get in reality is something like this. The problem started with the fact that the designers and developers were relying too much on a source, and they were being replicated and duplicated along the way. The absence of modularization, both in terms of design as well as the UI code, led to a kind of an exponential growth of software code that couldn't be maintained anymore in a modular way. The absence of modularization led to code duplication, and code duplication led to the fact there's impossibility of reusing your code. There were too many small differences along the way that kind of multiplied over one another, and then you ended up with kind of a rather amalgamated view of a product experience that became a composite of these differences that put together. As a result, you started seeing inconsistency in visual languages, which kind of leaks into your brand and the value that it brings. Inconsistency in interactions. One of the bar charts, when you click, was starting to drill down on the data. The other one did not interact. The other one showed me a tooltip, while the other one took me to a different page. These kind of interactions kind of diminish the affordances that you built into a chart to begin with. And last, all these unexpected and ambiguous behaviors that you brought into the system kind of builds over one another, and you make the user relearn the interaction over and over again per instance of a chart. The picture that you see on the left could actually be visualization and data agnostic. We could have been talking all along about a UI system, and even the session could have been titled Designing the Experience for UI. This is the same problem that existed in the UI in the early 2000s. This is not unique by any means, or first of a kind by any stretch. Replace the charts by text boxes and form fields, you have the state of UI products in early 2000s. But what happened? But what happened was the UI screens in the early 2010s were transformed by these design systems that brought in uniformity and consistency across a multi-product portfolios. What happened then should happen now with the visualizations of 2020 with the visualization design system. So you reinforce these consistencies not just in some parts of the UI, but in your complete data experiences in your product. This system will kind of lower the cost of UI development. Visualization, as most of you might know, is kind of a hard skill to find in the market, and is usually associated with high cost of development, both in terms of time and dollars. So now that we understand the need of a design system, and let's say we buy into the idea of having a system to drive these data experiences, we are left with two options. One is I could adopt a design system that's out there, or I could build my own systems. So what is the right option for me? The answer to this one is the age-old designer's classic response: it depends. But what does it depend on? It depends on a few things. It depends on how important is data experience to your overall product experience. Does it mean that is that a big chunk that is worthy of an investment from your company's perspective? It talks about it depends on how big your UI and UX team is. Do you have the enough resources, both in time and in personnel, to dedicate it to building the system? And what does your product roadmap look like? Is this just a one-off data experience or a visualization that you're doing? Or do you see more of this in the future? To help with this right option, we could look at what happened with UI systems before, because this, we said, was not a first case of a problem. So this one is a chart from a state of the UI design systems published by Google in late 2019. It looks at the organization size as a function of percentage of organization that decided to adopt a system versus build a system. And if you look closely, somewhere around the point of the 500 mark, you see that there's a switch between people preferring less to adopt a system and more towards building their own system here. Oh, I could do this, sorry. But if you fall in the first half of that graph, like you're a small team and you think probably it might not be worth to build a design system in-house and you want to adopt something here, you're again left with another question of which design system do I adopt? There's multiple ones in the market that are very popular: the Material Designs, the Apple Guidelines, the IBM Design, and a few more consumer products-driven design systems. Again, the answer is it depends. So you want to pick the design system that's closest to you, closest in terms of visuals, personality, and the goals of your business. It also depends on the UI framework that you have currently built so far. Because there's a lot of investment that's gone into the UI, you might not be able to bring in a framework that doesn't play along well with you. So that might define your choice here. And the third one is, how dependent are you about community support? Like typically UI systems that are public are maintained by community and they add new components. So you're going to answer the question of, if I need a new data chart tomorrow, am I going to build it in-house, or am I going to rely on the community to build this further? If you look at the community adoption as a way of helping you make this choice, you find that Google's Material Design has probably the most adoption, but the other ones are catching up, and they have, in fact, grown a lot significant over the last few years. But let's say you went to the other choice of which meant you were building the design system You're building the design system in-house. What does that mean to you? You start with the question of how versatile or how comprehensive do I want this design system to be? In fact, I would classify these design systems in a scale of what I call as a maturity. So in stage 0, a design system exists in an organization by word of mouth. Your design system is undocumented. Your designers are communicating it orally with UI developers, and the UI are just like communicating in person or in like any form of a structured documentation. In stage 1, these design principles kind of go documented into a set of design guidelines and design components. This is what the designers use typically in the form of sketch assets and other visual assets to replicate and make these mockups. This is the stage 1 of the system. The stage 2 is when these design documents actually become tangible forms on the UI, where a UI engineer takes this up, builds components that adheres to their guidelines, and you come out with libraries. And stage 3 is when your organization or the team is confident enough and the business reasons to actually like put this out in the market as an open source, letting the community join in and like build more out of it. So back to the question of when you're trying to build your design system and you ask the question of how versatile should my design system be, the answer here is not it depends. From the issues that we have seen around scalability and the consistency and the business operations of code replications and all those nasty things that came up with multiplying of codes, you need a minimum of stage 2 to actually solve for those problems. Anything in stage 1 means that UI code is still being replicated and you don't have the consistency built into something that's being delivered. It lives in your books down in the design side, but nothing gets shipped out in a consistent way out of your organization. But at this point, you do not forget the importance of stage 1 of the system. Having a stage 2 doesn't mean that you lose stage 1, because stage 1 stands to be a state of truth when you bring in another design system on another product and kind of unify it. If they are on a different framework, they become the source of truth for them to build a new design system on a new framework, so that all your product portfolios play along really well. And if you can really challenge and build a quality product and you have the resources, it might as well be worthwhile to go into stage 3, where you democratize the process and bring in more people to support and build this design system going forward. Pardon me here. So good design systems takes like months to initiate, and actually it takes years to get to a point where it's actually considered comprehensive. And it's a lifelong journey, and it's a marathon that you run with it. There's no end date to it, and you always have a team that's dedicated to it. The biggest mistake that one could do with this approach is believing that a design system is aimed to improve the efficiency between a designer and a developer. You're putting a system in between them, hoping for an improvement in efficiency, and that does not seldom come out the best way. Your motive to introduce a design system shouldn't be to make these people work less, but then work better. And this comes with a great understanding of the existing teams and process in your organization. You are adding some more process and operational frictions into it. So unless you understand the ecosystem of your relationship between your designer to developer to production and even releases, you might have to be wary of it and consider those factors when bringing in a process or bringing in a system. And building a design system gives you an opportunity to be personalized to your business. It has to be centered around the goals of your product, and that makes it unique to you, and that makes your solution unique to you. Your successful design system is not domain agnostic. It is something that understands the domain, understands the features and your product goals, but then is able to deliver value in a scope that's broader than the current day. So let's build a visualization design system. We forgot our lemonade story for a little bit, so that means it needs a little bit of recapping. So to recap, the designers and developers were relying too much on copy paste. When developing the UI, there was a lack of modularization, leading to duplication and impossibility to reuse the code. The minor differences got multiplied, and they were all over your multi-product portfolio, which meant there was higher cost to build and maintenance was a nightmare. So baselines. So these are kind of the philosophies with which you go into designing this, designing the visualization system. Now that you have been on day N, you have the advantage of understanding the use cases the product is solving for. So you now take a holistic approach to understand the use cases and drive those into the design decisions in your design system. You build consistency into the components, both visually, traction, and also account for scale into them. We look at that a little bit in our examples here. And most important of all, the one that will help you stand the test of time is building these components in the modular, reusable pattern. So now that you know your product really well, our lemonade store, and our technology that was driving it, let's kind of look at the different products and features, the store product, inventory. I'm just making this up, but you understand that a couple of charts in them. For example, maybe stores had a chart that was showing you juices sold, and maybe an inventory was having a chart of your product's supply chain. And you kind of map each of these charts into the type of visualization or the type of chart they represented. For example, the juices sold was representing a composition of different juices being sold, the strawberry mango versus the regular lemonade. A weather versus sale was trying to see the impact of a temperature on the sales. So it kind of talks about the distribution of sales based on the temperature. So you kind of group these different charts that existed into your product into chart types. Now you kind of lend a structure to it. There was visualizations that was mapping, that was presenting data of a current state, and some were visualizing data over a span of time. And I further classify and bring structure into like distribution ones, visualizations that were representing distribution, maybe distribution of sales across my shop, the nutrition value in my juices, while composition could be seeing the breakdown of juices that were sold today, the artificial percentage of artificial sugar in juices and examples, and something like visualizations over time would be something that is helping you forecast sales, forecast revenues, or something that compares to a time in history. The challenge with lending a structure to a system like this is it always brings friction in a creative field. One would, and actually one should argue that bringing structure would hinder the creative freedom of exploring new ways of presenting data. If you look at classic visualization examples, like the one that you see on the left is the map of the Russian campaign in 1812. It's one of the most documented visualizations, and has been considered one of the classic examples of visualization where it narrates a story. The other one that you see is one of the famous TED Talks from Hans Rosling. Rings a bell. So he talks about how poverty and different diseases in history have accounted for fatality and life expectancy in different countries, developing and the developed countries. So these, if you put these into structures, they don't really convey the power of the visualizations or the narrative quality of it. So what it means is when you realize that you're bringing structure to a creative process, you also should have the scope to preserve the creative freedom and the artistic license that comes in this field. So with that in mind, with that in mind, let's bring back the conversation of having the structure and the modular framework in a design system. The classic example of building systems was given by Brad Frost, the atomic design model. I think most of us in the room would have heard it in one form or the other. It's nothing but a chemistry and a biology put together in my head. It talks about how atoms combines to molecules, molecules fall organisms, and organisms translate into templates and pages. What this means in terms of, I'm kind of augmenting it with the subatomic particles or quarks in my example here. What it means is in terms of a UI design system, it's how these iconography and typography combine to form these text boxes and drop downs, and a drop down and a text box combine to form your select box. The select box happens to be in a form, and the form could be in a wizard or in a page of its own. Let's draw analogies from there, and as we build this visualization system. So in a visualization system, your quarks are formed by shapes, line widths, and spacing, kind of the building blocks of every chart and common charts that you see. So you construct these atoms called molecules, which also takes into account the color palettes of your UI system. Your WIS system does not exist in independence from your UI system here. Then you build these molecules, which talks about interaction between different entities. And then your organisms become these charts. What we also said was, how do we preserve the freedom that comes with a creative space like this one? So instead of calling it a system, I actually like calling it a guideline. So there is design patterns that form the first three levels, and the organisms are actually design examples. So in your system, they just form an examples and not become a strong rule that you have to be following every time you build one. What this results in creating a void on the right that helps you build more charts and bring in more creative thoughts into it, but still combining these molecular pieces that drive consistency and reinforce consistency into your visualizations. So let's go back to the structure that we did. So we classified all our visualizations in the product into these 5 buckets. And over the model, we built different chart types. Now we replace these use cases with the chart types in them. For example, a distribution could be represented by a bar, a stack bar, or a heat map, or a geographical distribution. And for example, a composition could be a pie chart, a radar chart, or a bar chart again, or a stack bar chart. Similarly, we do that for the other one. You start to see that a single type of chart actually starts to appear in multiple distribution types. So now you've got a finite set of charts from your use cases that you might need to build as a minimum requirement for your design system to be driving your product UIs. When you build these design examples or design charts, you also build these components and molecules that form them, the foundation elements, if I may. These things form your foundation to your whole structured system above. And with your design guidelines, that helps the designers choose the right data model or the right representation for these visualizations. It gives you it also preserves the space for you to look at non-conventional and narrative charts that might be built over the same foundational elements, lending consistency again. So what are the considerations? And we look at some consideration and samples of our design system. Visualization system, when we talk about, we tend to talk about just charts, but it's also more about your object relationship diagrams, your flow diagrams. Anything that's a non-tabular presentation of information is what I would call as visualization. But since we are looking at considerations and it would be easier to stick with the basic ones, the examples that we might see on the next slides are fairly basic, just to drive home the point of different considerations you make when you design a system for visualizations. First, beginning with the hierarchy. Your design system typically composes of a UI design component on it. Sometimes if on a richer system, it stands as a sibling to your illustration and your content, voice, and tone guidelines of your product. Your visualization system is kind of a stepchild of your UI design system. It borrows more properties from it, but stands as a sibling to your illustration and content and voice. It borrows your foundation elements of color, tones, and the typography from the UI system. It borrows the personality from the content, tone, and voice. What I mean by personality is it could be reinforced in the form of animations or the visuals that you use to represent these charts. And from the illustration, it kind of informs as well as is informed by the shapes and tones that's been specified as a part of illustration system. We talked about color palette a little bit. You always build the color palette of a system, of your visualizing system, on top of your UI design system. Here, you might need a few more tones just to talk about the bar charts and different distribution charts. Here you might need a different consistency when you talk about click and hover. So you make sure that the hues of your palette colors are adjusted by equal distances apart. Think about placing these colors on a sequential axis so that when you test for accessibility, there's enough contrast of these basic colors when they are juxtaposed with each other so that your bar charts read better. The next consideration would be consistencies. Consistencies beginning with interactions. It could be interactions within the chart types of a same chart type. For example, it's a hello. You good? So it could be between the different charts of the same type. For example, what you see is a horizontal bar chart, a stacked horizontal bar chart, a grouped horizontal bar chart, and a vertical bar chart. You're looking at a hover interaction that behaves and reads the same way across a single type of chart. Now, extending this to multiple charts as well. Your line charts behave the same way. Your this one's supposed to be area charts, are pretty washed out on the projector, but you get the idea that you're carrying over a similar interaction pattern across different chart types that you've built. Next is scale. Scale in terms of drilling down of this data. For example, if you take a donut chart here, how do I build the affordances to inform the user there's like more data or can break down the data further? And when you break down, I see different segments of the data. And then I can get more information about hovering over it. Carrying the same interaction pattern forward, you can something to that. Okay. So considering the same interaction patterns and the same kind of same interaction patterns on bar charts, you click on a bar and then break down the bar further. Also, if you notice, you would start seeing a cursor that's built in here for clicks and a regular hand pointer for clicks and a regular one for this for hovers. But you start to see these micro interactions and these smaller changes that may not be great affordances, but when you build these over a system of charts and repeat it, you preserve the learning of a user from one chart and carry it over to the other so that there is no relearning of these interactions that happens across these charts. You start to build scale into your charts in terms of quantity of data. The example that you see is how we have built scale into the volume of data that a bar chart could consume. It started with a wider bar width into a narrower bar width, and once it's beyond the threshold, it starts to bring in a slider that helps to see. So you start building these qualities of scale into each of these data charts. Scale coming in as an afterthought kind of breaks these patterns and kind of makes it hard for you to build over it and kind of creates the inconsistencies that we talked about earlier. Then you think about scale in terms of the types of screens and the widget sizes. Let's go the Starbucks way of calling it tall, grande, and venti. So we had a donut chart with a lot of information. Maybe this is great for web screens. How do you compress the data for maybe mobile screens? Maybe I don't have the breakdown, maybe I don't have a detailed breakdown, but kind of compress it into a legend. How does it go on maybe a smaller screen, maybe a smaller widget on a phone or even a watch, considering a smaller circle where only the key information is displayed? Thinking about the same scale in terms of screens and widgets from the point of view of interactions this time. You're looking at two sizes of a stack chart, two sizes of a bar chart, and when I'm going to click on each one of click on the one on the left, the breakdown happens and the new information is displayed in place. While on the right one, I have the freedom of more space, so where I could overlay more information on it. So here you're accounting for two things here. One is the amount of information and the size in which your base component is being presented. You also think about the edge cases and the error cases in this chart. For example, the bar chart, we were showing how the 0 values versus no data values being represented against washed out. And in terms of pie charts, you kind of handled this gracefully that if one of these information is not available, you may not be able to draw the whole portion of the pie, but you still degrade gracefully by showing other data values in it. And in terms of line chart, you may be able to do a little more by showing you other data points by just leaving the point blank. So the takeaway here is kind of handle these errors, but then whenever you can show information, show, but handle it more gracefully. A few key lessons that I learned along the way is one, democratize but prioritize. Do not make this your tool. Democratize the system so that there are more people contributing to it, even if it means they are breaking it. It tends to test the extent of your system. It tends to test the boundaries, but then you always learn from others, but make sure that the decision is held in the interest of consistency and you make the decisions of priority. Manage these expectations. Don't make yourself to think that, or let others think that this is something that's going to be a solution for everything, but kind of focus on the important pieces and prioritize. It might be tempting to do everything at once, like build the whole design system and then change the whole world, but it never works that way. And it's always good to have an understanding of what your product does, what you need in the future, and kind of prioritize your way along it so that it can help you help working with the developers a lot more easier. You can't push change until you deliver the value first. So, and it always makes sense to take the small step, but a strong step forward. And design for people, and every UX talk should end with this or should have a statement around this, because the first method of building these charts did not work because it only took into account the end users as a persona for the product. It never considered developer and designers in the ecosystem of users that it's being designed for. So when you design a system, those are your key stakeholders. Your problem or your product that's solving a use case comes in a secondary. So you are designing for people that are working with the system, and having them as the centerpiece or the linchpin of this process will keep you honest going forward. I think this gives me a good point to hand over the baton to the next speaker in the series. I believe he would be talking more about how do you get traction and execute the design system forward on March 10th. All right, so closing out, summaries and key takeaways. Think modular, always build over building blocks. Our childhood Legos have been a great teacher, and that's something that we carry over to our design systems. Structure, bring structure, but preserve freedom to it. Structure gives you consistencies, but it doesn't let you explore other ways. So when you think structure, think about freedom as the other flip side of the coin, and how do you blend this into your system together. And always think scale first. Scale visualizations are solutions to scale. And if you don't think scale as a first when you design these systems, it's going to be hard to retrofit in. And with that, I've wrapped this up. Thank you.
Who has a question for Brighton? You pass these down, please.
Hi, so I had a question regarding scale and interactions. Just kind of what your thoughts are on the affordances for mobile devices. There's no hover state, obviously. Like, how do you encourage discoverability in data when there's no cursor, essentially?
The mobile has always been an interesting part with visualizations, because in visualization, the interactions are always not familiar with the user. You are creating new ways depending on what they know. And with mobile, you have taken away one dimension, which is the hover. So you are always looking at, if there is an information on hover that I'm presenting on a web or that I intend to present, is that one, you ask yourself a question, is it important to be known to a user on a smaller screen space? If so, do I augment it, maybe just like giving a breakdown below it, or maybe having a flip view on click on stuff? So it depends on the context. Again, I'm giving an it depends answer, but then there are other ways of handling these secondary informations, and it tends to be different between a web and a mobile when you take away a dimension of interaction.
So first of all, I enjoyed this talk very much, and one of the recurring themes that you have throughout this that you kept repeating is that I find rather interesting is that data needs to tell a story. Now, in my experience as a researcher, I've found that it can be all too easy to misinterpret data by seeing a story that's not really there. So do you think there are ways in the scheme for visualizing data that can make it easier to fall into that trap?
That's a great question that I kind of did not address in the presentation. So this one part of it is the system that drives this visualization. The other part of it is the principles that you take forward with your system. The principles of being clear about the data, being precise about the data, and not having like a dark pattern or like misinterpretation of data. Maybe in a field like journalism where you want certain takeaways to be done, there can be ways or visually manipulating graphs, like changing the baseline of your bar chart towards making users think about the data in a different way. So those may be coming across as dark patterns, but to you and your business goals, those may be the right things because you want the user to think that way. Though there is questions of ethics that comes with presenting this data in a misinterpreting way. So yes, so the part of it that has to deal with it or address it is the principles. And usually a design system has like these 3 key principles that they try and adhere and reflect on the personality of the UI, visual, and the illustration system. And I think that has to be encoded within that to carry forward into the product.
Thank you. Thanks, Ed. Brighton, great presentation. I loved all the analogies and metaphors. It's actually thirst quenching. I wanted to ask you 2 things. Okay, one is you talked about grouping or bucketing data correctly, right? And it's very easy to not connect the right dots. Okay, and like he said, you can completely misinterpret the story or go off on a different trail and then figure out that, oh, you were chasing the wrong target all along. One, do you have guidelines to say, okay, these are the data points or this is the grouping or categorizing that I want to do? And secondly, how do you forecast design for scale? Because if you're starting out or if you're in the 500 mark, is it based on in the next so many years, I want this design to kind of catch up that way? How do you do it?
Trying to answer 2 questions here.
Yeah.
One talking about the bucketing.
Yes.
And the second about the scale.
Yes.
Let me take the first one first.
Please.
So you talked about bucketing. I think you were mentioning to the slide where I talked about use cases into classifying of different data visualizations. So I think there's a definite range of error tolerance there. If you did bucket in another way, you're still mapping it to the type of chart and it's just lending a structure to your visualization system. For example, a UI system would have like your form fields, text box, radio buttons, and checkboxes, and maybe have wizard steps as another component. Just replacing them in another bucket, even if you make a mistake the first time, you have the opportunity to move it. I don't think that is really critical to get it right. Okay. I think the whole part of it is to see those affinities and bring structure to it. Okay. And when you're trying to build a system, you'll always get some things wrong. And I think that's okay, and it's kind of error tolerant as you go towards it. The second question about scale is, how do you know what your product is going to look like and how far do you look into the future? The design. Yeah. That's a really hard problem for any designer in any field. It doesn't have to be visualizations. Exactly. And the ability to see forward comes with also how long has your organization been in the field? Do you have a clear roadmap and vision? So those are the things that play into it. When you're building a system, as far as you can see is good, the farther you can see is better. So you try and account for your directions into it, but there's always limitations to it, and you always build more into the system. So maybe your first version of your visualization system might not have a scatter plot or a heat map. They might come in when you see that, hey, none of these charts that I've built fit into the best ways of representing data. I'm thinking about a new form. Okay, now let's see. I have these axis legends from my previous charts. Let me take them, use the same color palette, and build new forms over it. I think it should be flexible enough to help you build more, at the same time preserve the consistencies.
Any other questions? Other questions? Anyone? Going once, going twice? Oh,
That's one.
wait, oh, where? Raise your hand up high.
So I'm kind of curious about how you would go about figuring out the right way to represent high dimensional data. You know, because most of the things you talk about is easily discernible in 2 dimensions,
Yes.
but lots of data actually has many dimensions. And how do you decide how to go about having the best representation?
I think this one goes into understanding the power of human perception as well. Humans are great at deciphering 2-dimension data. With 3, there's a loss of granularity. With 4, it goes this way. So you're always going to slice and pivot your tables. Like even the spreadsheets that we have today and the tables we have is working on the principles of filtering, sorting, and kind of refining the data sets that you do. So you kind of extend that one to the dimensions. Maybe if there are 4 dimensions, you try to see correlations between 2 at a time, or maybe 3 in a 3-dimensional visualization, which gets hard. So you see these perspectives and then drive it. It's a hard problem to solve when it goes more than 3 dimensions. And depending on the use case, you might be able to prefer 1 or 2 pivot points more than the other. Maybe sorting on these two dimensions and filtering by the 3rd dimension may be the best form for a particular use case. So understanding the use case in that front helps you make these decisions of from where do you pivot and how do you pivot.
Other questions?
Hey, Brighton. So regarding the analogy that you had about, looking at quarks going to atoms and molecules, when you're undertaking building a new design solution or design system, how are you how are you actually executing on that in terms of, are you decomposing, and I'm thinking in terms of the code that you're actually building, right? The stack or the framework you're building. Can you share your approach to that?
I'm not the best person to talk about in terms of framework componentizing, but I can share my experiences with my interaction with the UI engineer here. So in terms of identifying these blocks that can be independently used and consumed and repeated, those form the components in our framework today. So each one is a self-sufficient but a comprehensive set that has these interfaces that can plug in with different charts. Let's think about maybe legends as an example. So that becomes a component, and the legends can plug into your bar chart, maybe a line chart, and even a legend could be interactable, like I click on one and I hide that line. So those have these interfaces built into it, and you see them as a singular complete entity that forms a block that can be manifested with multiple charts. So that kind of seeing those minimum viable entities is key to identifying these factors.
I think that's helpful. Thank you.
All right. Well, please give Brighton a big hand here. I really enjoyed the storytelling in that presentation.